In part 6 of our lesson on applications of vectors, we will solve problems involving forces on a hill. Let's start off with a quick geometry review. Take a look at this diagram. We have three angles, A, B, and C, and we're going to review the theorem that two angles that are complementary to the same angle are congruent. So in this picture, if A is complementary to C, so that means angle A and angle C have to be complementary. Now remember that complementary angles add to be 90. So then you would know that angle A has to be 70 degrees. We are also told that angle B is complementary to C. So angle B has to be complementary to angle C, which means it would have to be 70. So then it really makes sense that the result of the theorem is that angle A and angle B have to equal each other. Since they both have to be complementary to C, that means they both have to be 70, so it makes sense that A is equal to B. Similarly, we have a theorem that says two angles that are supplementary to the same angle are congruent. So in this picture, if angle X is supplementary to angle Z, so here's angle X, it has to be supplementary to Z. We know that supplementary angles add up to be 180 degrees, so that means X would have to be 130 degrees. We are also given that angle Y is supplementary to Z. So here's angle Y, here's angle Z, so Y would have to be 130 degrees. So it makes sense then that the conclusion is that angle X and Z have to be equal to each other. To summarize here, if we know two angles are complementary to the same angle, then we know those two angles will be congruent. Or, if we know two angles are supplementary to the same angle, then we know those two angles will be congruent. In this example, we are given that a 5,000-pound truck is parked on a hill that makes a 12-degree angle with the horizontal. So let's start making a drawing. Here's our hill, and we know that it makes a 12-degree angle with the horizontal. So this angle here is 12 degrees. We'll put the truck on there somewhere, maybe here. We'll call it T for truck. Now the truck weighs 5,000 pounds, and we know that gravity pulls straight down towards the center of the Earth. So the vector force that is gravity will be perpendicular to the horizontal. And this is 5,000 pounds. we have to find the force required of the brakes to keep the truck from rolling downhill. So what happens is that the force of gravity gets broken up into two parts. The part of the force that is perpendicular to the hill and the part of the force that is parallel, going in the direction of the hill, which is this force right here. And that is the force that's trying to pull the car downhill. So the brakes will have to counteract that force by essentially pulling uphill with an equal but opposite force. So the brakes will have to pull this way we'll say that vector B is the force required of the brakes. And we notice that vector B is just the opposite of vector F, which is the force pulling downhill. Because vector B is the opposite of vector F, we know that the magnitude of vector B is going to have to equal the magnitude of vector F. Now in this diagram, we have a couple of right triangles we can work with. If we look at this big right triangle, we see that the right angle is here, so that means the 12 degrees and this angle over here at vertex T, those two angles are going to have to be complementary. We know we have a theorem that says the acute angles in a right triangle are complementary to each other. So that means this 12-degree angle is complementary to the angle here at T. Let's call it angle T. Also look at the small right triangle here, and we see that angle T is also in this small right triangle. So that means this angle right here, let's call it theta, that means that theta is also complementary to angle T, because in this smaller right triangle, the acute angles have to be complementary. Now, we just reviewed a theorem that said that two angles that are complementary to the same angle have to equal each other. So the 12 degrees is complementary to angle T, theta is complementary to angle T. So now we're going to apply the theorem that says two angles complementary to the same angle are equal. And that tells us then that theta has to be 12 degrees. So we can mark that in our picture. This angle is going to be 12 degrees. Now, because of this small right triangle, we know that we can use SOHCAHTOA. Anytime we have a right triangle, we are allowed to use it. Relative to the 12-degree angle, the magnitude of our force is the opposite leg. The 5,000 is the hypotenuse. So if we have opposite and hypotenuse, that means we're going to be using sine. And we can say that sine of 12 degrees has to equal the magnitude of the force divided by 5,000. Cross multiplying that 5,000, we get 5,000 times the sine of 12 degrees on the left-hand side, and we have the magnitude of vector F on the right-hand side. Now we can enter this on our calculators. 5,000 times the sine of 12, and rounding to the tenths place, we get 1,039.6. The units will be pounds, and that is the magnitude of vector F. So that is the magnitude of the force pulling the truck downhill, which means that vector B, the brakes, have to apply that equal and opposite force uphill to keep the truck from rolling down the hill. So because magnitude of vector B is equal to magnitude of vector F, we now know that the magnitude of vector B will be 1,039.6 pounds. So we can say that the brakes must apply 1,039.6 pounds of force to keep the truck from rolling downhill.